You've probably seen rare earths popping up in the news every now and then, usually in some story about tech wars or China's market power. But what's the big deal? And why does it feel like China has the cheat codes for rare earths? Well, stick around. Today we're breaking it down. What rare earths actually are, why the West struggles to produce them, and how China managed to corner the market. First off, plot twist, rare earths aren't really that rare. They're mostly 15 elements on the periodic table, called the lanthanides. In fact, the Earth's crust has more rare earths than copper. And compared to gold, try 40,000 times more. So, why the misleading name? Blame an old Finnish chemist back in 1794 who found some weird oxide that wouldn't melt, wouldn't dissolve, and just seemed odd. Scientists didn't know what bucket to put it in, so they slapped the label rare earths on it. The name stuck, even though we've since found these things all over the planet. So, yeah, rare earths are about as rare as pet videos on YouTube. Now, when we think of industrial raw materials, most people think copper, iron, aluminum, the usual suspects. But in today's high-tech world, rare earths are more like the vitamins of modern industry. You don't need a ton, but without them, things stop working properly. Their funky electronic and chemical properties make them the secret sauce behind a lot of cutting-edge tech. Take magnets, for example. Not your fridge magnet. Think the neodymium iron boron magnet, also known as the king of permanent magnets. This beast is the strongest magnet on Earth. Thanks to it, we can build motors and gadgets that are smaller, lighter, and way more efficient. Rare earths also play the role of fairy dust in good old-fashioned industries. In steel making, sprinkle in a pinch, and suddenly your steel is purer, tougher, and easier to work with. In aluminum or magnesium alloys, they boost heat resistance and durability, perfect for aerospace. Basically, rare earths take boring old metals and give them superhero upgrades. And when it comes to defense and aerospace, rare earths are completely irreplaceable. We're talking tank armor, fighter jet engines, missiles, satellites, you name it. Neodymium is used in laser rangefinders for tanks. Samarium cobalt magnets keep space electronics working, and rare earth coatings in jet engines literally stop them from cracking apart at thousands of degrees. Without rare earths, modern militaries would be fighting with slingshots. But here's where it gets tricky. It's not the amount of rare earths that's the problem, it's the purity. These things have to be refined to almost comically high standards. We're talking 99.9999% pure. Why so picky? Because even a speck of impurity can ruin everything. In civilian tech, that means shorter battery life or weaker motors. In aerospace or defense, well, imagine a jet engine deciding to explode mid-flight. Not ideal. That's why rare earths are ranked by purity levels. 3N means 99.9% pure, 4N is 99.99%, and so on up to 6N, which is 99.9999%. For reference, high-performance magnets need 4N to 5N. Laser crystals? Same. Electric vehicle motors? At least 4N. Drop below that, and its magic effects quickly degrade. And that insanely high standard is one of the big reasons why rare earth production is so hard.
Now, why did the U.S. lose their rare earth industry? In short, rare earths are kind of the worst business model ever. They're not super profitable, they're ridiculously complicated to process, and the risks are sky high. Not really a recipe to attract big investors. To put it in perspective, the world uses about 1/100th as much rare earth as it does copper every year. And the price? Usually only a bit higher than cobalt, unless a trade war throws everything out of whack. So basically, small demand, modest prices, thin margins. Not exactly Wall Street's dream. But here's the kicker. Mining rare earths isn't actually the hardest part. The real nightmare is separating them. Rare earth elements are like identical twins. They look similar, act similar, and hang out in the same rocks. Splitting them into pure, usable elements takes some of the most advanced chemical engineering on the planet. The process? Buckle up. First, you crush and concentrate the ore. Then you roast it with acids or bases. Then comes leaching, precipitation, and countless rounds of solvent extraction or ion exchange. Translation, it's messy, it's expensive, and it leaves behind mountains of toxic sludge. And it gets worse. Rare earth deposits often come with uranium and thorium tagging along, both of which are radioactive. Even tiny amounts mean you're not just dealing with chemical waste, you're now dealing with radioactive waste. By estimation, for every ton of rare earths you produce, you get about 75 tons of chemical wastewater and a full ton of radioactive waste. That's not exactly the kind of byproduct you can sweep under the rug. Venture capitalists already hate dealing with toxic waste. Add radiation, and they'll sprint for the exit. Here's the twist, though. Back in the 1960s and 70s, the U.S. was actually the king of rare earths. A company called Molycorp ran giant mines in California and dominated the global market. In fact, China had to ship its raw rare earth ore to the U.S. for refining. Yep, America was the one holding the keys. Then came 1980. Because refining rare earths produces low-level radioactive byproducts, the U.S. Nuclear Regulation Commission decided to reclassify rare earth mining under nuclear regulation. Overnight, every waste pond, every tailings pile, every facility had to follow strict nuclear safety rules. Costs went through the roof, and the industry began to collapse. By 1998, Molycorp shut down its main refining lines, pulling the plug on heavy rare earths completely. For years, America basically had zero commercial refining capacity. Washington didn't wake up to the problem until around 2012. But by then, China didn't just surge ahead, it was dominating the field.
To understand how China pulled this off, we've got to rewind a bit. Back in 1950, China formed a strategic alliance with the Soviet Union. That alliance basically put Beijing on the West's no-tech sharing list. With embargoes blocking them from Western know-how, China became laser-focused on one thing: self-reliance, especially anything tied to national security. By the 1970s, Chinese scientists had their eyes on rare earths. The government was ready to pay the price, financially and environmentally, to master the refining process and build a full supply chain. The big challenge wasn't just pollution, but also the separation and purification process. Those 15 rare earth elements are like 15 identical brothers wearing the same outfit, all acting the same at a party. Good luck telling them apart. To hit those 99.99% purity levels, you needed some next-level chemistry. At first, China didn't have the tech. The gold standard was owned by a French company called Rhone-Poulenc. Their secret sauce was a solvent extraction process, which in plum English means dumping rare earth soup into special machines and shaking it with solvents hundreds of times over months until you finally get pure rare earths. Outsiders knew what they were doing, but the critical how was locked up tighter than the Coca-Cola recipe. And here's the kicker. Every rare earth deposit is unique. Even Rhone-Poulenc had to spend over a year recalibrating their process for each new source of ore. For China, that meant shipping its raw material to France, then buying it back at dozens or even hundreds of times the price. Basically, China was stuck playing raw material sidekick. Enter Zhu Guangxian, the game changer. Zhu was originally a Chinese nuclear fuel expert, but in 1972, he was tasked to solve the rare earths challenge. After nearly a decade of grind, he cracked it, developing a new theoretical framework and a cascade extraction process that put China on the map. By 1986, China had already leapfrogged the U.S. in production. In the 1990s, they weren't just competing, they were dominating. supplying over 2/3 of the world's rare earths. In 2025, China accounts for about 60 to 70% of global mining output and a jaw-dropping 85 to 90% of global refining capacity. Meanwhile, the U.S. let the free market deal with it. Problem is, the free market dislikes industries low on profit and yet high on pollution. By the late 1980s, China could deliver high-quality rare earths dirt cheap, thanks to better chemical engineering and, let's be real, weak environmental rules. So American investors took one look and said, no thanks, leaving China to run with it. For decades, Western companies literally shipped raw ore to China, let China deal with the messy refining and pollution, and then bought back the finished product for bargain prices. It was all good until trade wars disrupted it all. Fast forward to today, and China has gone from cranking out 3N purity rare earths in the 1980s, that's 99.9%, to producing industrial scale 6N purity, that's 99.9999%. Modern Chinese plants are automated, digitally controlled, and running with near closed-loop waste systems. In other words, this isn't the cheap and dirty image people still imagine. It's advanced, efficient, and way ahead of the competition. China's dominance didn't just happen. It was the result of decades of strategy, treating rare earths as a national priority, accepting the environmental costs, and steadily building world-class refining technology, while the West shrugged and looked the other way. When the U.S.-China trade war erupted, both sides aimed at each other's critical supply chains. That's when Washington had a bit of a wake-up call. The U.S. rare earth industry wasn't just behind, it was decades behind. Here's the problem in plain English. America lacks production capacity at the lower purity end and tech know-how at the higher purity end. Experts say that if the U.S. really threw money and brainpower at the problem, it could probably get to producing 4N or 5N purity rare earths within 2 to 3 years. But hitting 6N purity is a whole different ballgame. Think 5 years for light rare earths and closer to 10 years for heavy ones. Meanwhile, China is casually mass-producing all rare earths at 6N purity, with some even at 6.5N. Their R&D is already poking at 7N purity, basically chemistry on God mode. And here's the irony. Despite being a high-tech field with huge barriers to entry, the rare earth business isn't actually that profitable. Remember, they're the vitamins of modern industry, essential but used in tiny doses. Most high-tech products only need a few dozen grams of the stuff. Add in the pollution cleanup headache, and you see why private investors stay away. But this is exactly why rare earths are such a powerful weapon in trade disputes. If a producer sells less, they don't lose much. But the buyers suddenly can't build fighter jets, missiles, or electric cars. The producer shrugs, the buyer panics. That's why rare earths are so effective as leverage. The lesson is this. Better not start a trade war against anyone holding such aces. The smarter move would be cooperation. Countries trading resources and tech, each side playing to its strengths. If that ever happens, a lot of today's rare earth drama might not matter anymore. But until then, rare earths are staying firmly on the geopolitical chessboard.